This is an example of a simple intelligence problem. It describes a situation, a question to answer, and additional available information. We have to find the most likely answer to the question based on the available information, which is generally incomplete, uncertain, and contradictory. Let's read this problem description carefully because we will use it to teach you how to solve this kind of problems. Today's Washington Post published an article that concerns how safely radioactive materials are stored in this general area. Willard, the investigative reporter and author of this piece, begins by noting how storage of nuclear and radioactive material is so frequently haphazard in other countries, and wonders how carefully these materials are guarded here in the United States, particularly in this general area. In the process of his investigation, the reporter notes his discovery that a canister containing cesium-137 has gone missing from the XYZ company in Maryland just 3 days ago. The XYZ company manufactures devices for sterilized medical equipment and uses cesium-137 in these devices along with other radioactive materials. This piece arouses your curiosity because of your concern about terrorists planting dirty bombs in our cities. The question is the cesium canister missing from the XYZ warehouse? And here is the available information. Contacted about the cesium-137 canister, Ralph, the supervisor of the warehouse, reports that the cesium-137 canister is registered as being in the warehouse, that no one at the XYZ company had checked it out, but it is not located anywhere in the hazardous material locker. He also indicates that the lock on the hazardous material locker appears to have been forced. We will now illustrate the process of developing an argumentation for this problem. We start with the intelligence question. Is a cesium-137 canister missing from the XYZ warehouse? Based on the problem description, we need to imagine the possible answers to this question. An answer may be expressed as either H or not H, depending on which one looks more probable. In this case, we decide on a single hypothesis to investigate. The cesium-137 canister is missing from the XYZ warehouse. We now have to determine how to decompose this hypothesis into simpler sub-hypotheses that are supported by the available information. Let's review this information. Contacted about the cesium-137 canister, Ralph, the supervisor of the warehouse, reports that the cesium-137 canister is registered as being in the warehouse, that no one at the XYZ company had checked it out, but it is not located anywhere in the hazardous materials locker. He also indicates that the lock on the hazardous material locker appears to have been forced. This information suggests that we may decompose the top hypothesis into the following sub-hypotheses. The canister was in the warehouse, the canister is no longer in the warehouse, the canister was not checked out from the warehouse. This is an argument or reason for the hypothesis to be true. We also need to assess the relevance of this argument by answering the question. Assuming that the sub-hypotheses are true, what is the probability of the hypothesis? In this case, the sub-hypotheses represent a sufficient condition for the top hypothesis. Therefore, the relevance of this argument is certain. In general, we could distinguish between two types of arguments: sufficient conditions for which the relevance is certain, and indicators for which the relevance is less than certain. We next have to determine which is the relevant evidence for each hypothesis. Evidence is any item of information which assists in proving or disproving a hypothesis. Ralph is telling us that the cesium-137 canister is registered as being in the warehouse. This is an item of evidence that favors the hypothesis that the canister was in the warehouse. Whitler reports in the Washington Post, together with Ralph's statement that the cesium-137 canister is not located anywhere in the hazardous material locker, are both items of evidence that favor the hypothesis that the canister is no longer in the warehouse. Finally, Ralph's statement that no one at XYZ company had checked the cesium-137 canister out is an item of evidence that favors the hypothesis that the canister was not checked out from the warehouse. Notice that in each of these examples, an item of evidence is a short statement from the problem description. In general, an item of evidence is a statement about the occurrence or non-occurrence of some event. The goal is to determine the probability of that event based on all the items of evidence which are relevant to it, as will be explained next. Evidence is any item of information which assists in proving or disproving a hypothesis. Here is how we can determine the probability of a hypothesis based on one item of evidence. First, we need to assess the relevance of this item of evidence to the hypothesis by answering the following question. Assuming that the evidence is true, what is the probability of the hypothesis? If the cesium-137 canister is registered as being in the warehouse, then we assess that it is almost certain that the canister was in the warehouse. Next, we need to assess the credibility of this item of evidence by answering the following question. What is the probability that what the evidence is telling us is true? Here we do not have much information about Ralph except that he is a supervisor of the warehouse. We will assume that his credibility is very likely. The third credential of evidence is its inferential force. What is the probability of the hypothesis based only on this item of evidence? The inferential force can be automatically determined as a minimum between the credibility and relevance. Thus, based on it too, it is very likely that the canister was in the warehouse. Here is a situation where we have two items of evidence that are relevant to the same hypothesis. What is the relevance of E1? Certain, because if the canister is missing, it is no longer in the warehouse. What is the credibility of E1? Likely. Therefore, the inferential force of E1 is likely. What is the relevance of E3? Certain, because if the canister is not located anywhere, it is no longer in the warehouse. What is the credibility of E3? Very likely, because this is another statement made by Ralph. Therefore, the inferential force of E3 is very likely. The combined inferential force of E1 and E3 can be automatically determined as a maximum between their inferential force. Thus, based on both E1 and E3, it is very likely that the canister is no longer in the warehouse. It is possible that we also have disfavoring evidence for a hypothesis. In that case, we also need to assess the inferential force of the disfavoring evidence. The probability of the hypothesis will then be determined by balancing the inferential force of the favoring evidence with that of the disfavoring evidence, as will be presented later. We now have all the elements for an automatic system such as Cogent to infer the probability of the top hypothesis. As just explained, based on the evidence, we have determined the probabilities of the simplest hypothesis. Then, the probability of the top hypothesis is obtained as a minimum between these probabilities and the relevance of the argument. Thus, Based on the available evidence, it is very likely that the cesium-137 canister is missing from the XYZ warehouse.